Hey everyone! Welcome to today's video, where we will delve into a programming problem that can arise when dealing with pointers and C functions. The problem we're going to tackle involves optimizing reads within a function that takes both non-const and const pointers as parameters. Intriguing, right? Now, let's talk about the solution to this problem. It's been proposed that in order to achieve the benefits of restrict for all reads within the function, it may be sufficient to only use restrict on the output parameters. However, this assumption comes with a crucial premise. Consider a function that takes a non-const pointer and a const pointer b, and within the function, b is read but not modified. In such a scenario, merely labeling as restrict while leaving b untouched by restrict could lead to the same optimization benefits, according to some tests. But hold on a second, there's a catch. Let's dive into a specific code snippet to better understand this. Imagine a function that prints the value pointed to by b, then calls another function bar, and finally prints the value of b again. Now, if bar potentially modifies the memory location pointed to by b, even indirectly, the compiler cannot assume that b remains unchanged and must reload it from memory for the second print statement. This showcases the limitations of relying solely on the const qualifier for optimizations. In summary, when it comes to optimizing reads within a function that deals with non-const and const pointers, the use of restrict on the const pointer parameter can indeed enable certain optimizations, especially in cases where the compiler has full visibility into memory modifications. It's a subtle dance between qualifiers and compiler assumptions. And with that, we wrap up today's video. Remember to subscribe, like, and leave a comment below with your favorite programming pun. Happy coding!